Hello, good night everyone. I barely found the time to do the lessons, but here they are. Section 3.3, dividing polynomials, remainder, and factor theorems. So this is basically telling us step by step how to do something, that is called long division of polynomials. So you can read this step entirely step by step on your own if you need further explanation after mine, but I'm gonna go straight to the examples. So here we're going to divide using long division, state the quotient, and the quotient is referred as Q of x, and the remainder, which is R of x. So long division, it's like if you're gonna set up little division house symbol, just like the ones that we know from elementary, and we are going to write down the polynomial, the first polynomial that you're given, or the longest one usually, inside of the division house. Now, there's something that is very, very important that you need to make sure before you start actually doing the process of the long division. You want to make sure that your polynomial is written from left to right, starting with the greatest exponent to the smallest exponent. And also the terms need to be written not only from left to right, from greatest exponent to smallest, but also they need to be written in consecutive order. So we start with a term here that has an x to the third power. The next term should be one exponent less than that one, x to the second power, and then the next term has an x to the first power, even though we do not see any exponent on the x. Remember that we always assume that it's a 1. And then the last term, which is the constant, the minus 20 or negative 20, that one has no x that we can see. So consider that to be an x to the 0 power, let's say. So if you check at your exponents are in decreasing order and in consecutive decreasing order. 3, 2, then a 1 here even though we don't see it, and then over here it's 0. So 3, 2, 1, 0, that's perfect, that's what we want. You need to check for that in the polynomial expression that you're going to write inside of the division house. On the outside one, they're usually set already like that, so you don't need to worry that much about that one. But that one also, if it was in this order, you also want to write it the same way that I'm telling you, starting from left to right with the greatest exponent to the smallest exponent, and one after the other. But I mean, usually that one you don't worry about. You worry about the first one, the long one that is given to you. And we'll see an example what happens if they're not written in that order, if they're missing one of the exponents in between two exponents. We'll see how to deal with that right now. So what's the process of long division? You're going to start by saying, okay, the first term on the outside, 2x times something, has to equal the first term inside of my division house. So this is like the question right now. 2x times something equals 8x to the third. So you have to think 2 times 4, okay, is 8. X to the first times x to the second power would give me x to the third. So then what I need is to put a 4x to the second power on top of my division house. So after you figure that out, the next step is going to be multiplying this 4x to the second times every term on the outside of the division. So 4x squared times 2x, you already know that it's going to be 8x to the third power. Now let me tell you something. Every time that you do this multiplication and you write the answer here below, and if you see it's on purpose that I'm writing the terms, below the terms that have the same kind of exponent. So you want to put like terms with like terms after the multiplication. You want to do the multiplication and say, for example, positive 4x to the second times a positive 2x. It's a positive 8x to the third power, but when you write it down here, you're going to put a negative sign on this term. Why? You're creating a subtraction. So every time you're doing that, you're multiplying the terms times -1, let's say. So do your multiplication and then do that answer times -1, or basically when we multiply times -1, we are changing the sign to the opposite of what they should be. So if a positive term times another positive term gives you a positive term, basically just write it as a negative. Change it to the opposite. So once you did the multiplication of the first two, you should not forget that you should also multiply the term on the top times the second term on the outside. So 4x to the second times a -4, it should be a -16x to the second. But remember what I told you. If the answer is a -16x to the second, you're going to multiply that -16 times a -1. That's going to change the sign to a positive. So that's what I'm telling you. For example, 4x to the second times a -4, positive times a negative, I already know it's going to give me a negative. So then just change it in your mind, change it to the opposite, which would be a positive. And that's it. So what to do next? Well, now you're going to combine like terms, and that's why it's important that you write the answers down after the multiplications underneath the terms that have the same kind of exponents, so that you align like terms. So 8x to the third power minus 8x to the third power, these two would cancel each other. And then -4x to the second power plus 16x to the second power, 12x to the second power. What to do next after here? You're going to bring down the next term, so -14x. So you're going to start all over again the process. Take the first term on the outside, multiply times something to equal to what? Again, you're going to equal it to the first term of the last answer that you have here. So to 12x to the second power. So 2x times what would equal 12x to the second? So 2 times 6, and x times x, right, would give me x to the second. So what I need to write down over here on the top next to the 4x squared, it's plus 6x, because I need a positive 6x. Start all over again. 6x times 2x, it's positive 12x squared. But remember, I told you when you write the answer here, change the sign to the opposite. So if positive times positive is positive, make it negative. 6x times a -4, it's a -24x, but when you write it here, you put positive 24x, because you're changing the signs to the opposite. And then combining like terms, 12x squared minus 12x squared cancels. -14x plus 24x, 10x. You still have a term, to bring down. So we bring it down, -20. Start the process again. Now you're going to say the first term on the outside, it's always that one, times something, has to equal the first term of the last answer that I have here. So it has to equal to 10x. So what could we put here? Times 5. So that means that up here we need plus 5. Again, 5 times the 2x on the outside, 10x, but positive times a positive should be a positive, but I'm going to change it to a negative on purpose. 5 times a -4, it's a -20, but when I write it here on purpose, I change the sign to a positive 20. So 10x minus 10x cancels, and coincidentally, -20 plus 20 also cancels. So what is left here? Nothing, so 0. So okay, it says for us to write the answer down, and it says on the instructions, state the quotient and the remainder. Well, in a division, in any division, okay, the answer on the top is what we call the quotient. So this is your quotient. Whatever is left at the bottom, sometimes it's 0, sometimes it's not. It's called the remainder, whatever is left. And then the outside part, it's called the divisor. Okay. The inside is called the dividend. So when the remainder is 0, your answer basically is just the quotient. That's what it is, and that's it. You don't need to worry about the remainder. So the answer would be 4x to the second power plus 6x plus 5. That's what your answer is supposed to be for this one. Okay. Let's do the next example. Sorry, I didn't quite show you the answer, right? Didn't set it to look enough there, but that's what it is. Okay, so it says use long division, divide using long division, state the quotient and the remainder. Okay, so long division, you already know how it looks like. It's a division like a little division house like the ones from elementary. And then we're going to copy the first polynomial or the top one inside of the division, except that if you check your exponents, 4, 3, 2, okay, so it looks like starting with 4 and then every exponent after that is consecutively decreasing, getting smaller, right? Consecutively means one after the other, so 4, 3, 2. So it looks like it's okay. So we put it here. And now we're going to write on the outside the small one. Okay. We start the whole process again just like the other one. Take the first term on the outside times something, ask yourself times what? It's going to equal the first term that is inside. So 2x squared times 4x squared would give you 8x to the fourth. So you would put here 4x to the second. 4x to the second times 2x squared, 8x to the fourth power. Remember what I told you. If positive times a positive equals a positive, you're going to make it negative on purpose. You're going to change it to the opposite. 4x squared times 3 should be positive 12x squared. But when I put it here, I'm going to make it negative on purpose. These two get canceled. And then 16x squared minus 12x squared is 4x squared plus 3, right? We have to bring down the next term. You start again. 2x squared times something has to equal 4x squared. So 2x squared times 2, just times 2, would equal 4x squared. So over here on the top, I put plus 2. I multiply the 2 times both terms that are on the outside of the division. 2 times 2x squared should be 4x squared. But remember that we're changing the signs to the opposite. 2 times 3 should be 6, but I'm positive 6, but I'm going to change it to the opposite, to negative. So what happens with the first two? 4x squared minus 4x squared cancels. 3 minus 6, negative 3. Now, is there something else you can do? No, because there's nothing left to bring down. So that's it. We stop. We stop at the moment that there's nothing else to bring down. So here, you can see that my remainder is actually something else, right? Like it's not 0 like the other one. This is my quotient. Remember that quotient we said it's written like this. And this is my remainder. Okay. Those are the two things they're asking you. State the quotient and the remainder. So when you do have a remainder that is not 0, you're going to write the answer in a special way. You're going to write quotient plus remainder over the divisor. So this should be in our case 4x squared plus 2. Now, plus the remainder, but if the remainder is negative, then you're going to put minus 3, that's the remainder. The divisor is whatever you are dividing by. You're dividing by 2x squared plus 3. So you're going to put 2x squared plus 3 as a fraction, like this, 3 over this. And that's what the answer is. And for quotient, remainder, and that, I mean, you can use capital letters, lowercase, it doesn't matter. Q stands for the quotient, R stands for the remainder, D for the divisor. Okay. When, like in the previous problem, when the remainder is 0, then you don't have to worry about writing the answer like this. You just copy the quotient and that's it, end of story. But here you have to write it like this form. Okay. So we already did 2 problems with long division. With synthetic division, it's a different process. You're dividing, you're doing the same thing as what you're doing with this one, but it's a completely different way of doing it. This is the way that I do synthetic division. The house, I put it upside down like this. Check for the exponents. That doesn't change. You have to have your polynomial reading from greatest exponent to smallest and decreasing consecutively one after the other. 3, 2, 1, and then nothing at the very end, right? 0. 3x to the 0, we can say. Okay, so our polynomial is written the way that it's supposed to be. So we're going to write only the coefficients. The coefficients are the numbers at the front of each variable in each term. 3, the next 3, the next -5, and then lastly the 3. If a number has a minus at the front, you need to carry that negative with the number. Now on the outside, what are you going to put? You're only going to write, remember, in synthetic division, you're not going to be using the variables when you're doing the division. I mean, to set up the division, no. So you equal x minus 3 equal to 0. You add 3 to both sides. So x equals 3, so you put a 3 here. Let me tell you something. This basically, like if it is x minus 3, it's usually the opposite of this minus 3. So it would be a positive 3, what you're going to use on the outside. If it would be, let's say, x plus 2, then you're going to use a -2 on the outside. You can do this long way of getting the value that you're going to use on the outside, setting this expression equal to 0 and solving for x. Basically, it's always the opposite sign of what you see here. But you don't use the x's at all. If you see, I'm not doing anything dealing with the x's. You're not supposed to. Okay, just the coefficients. So then, we're gonna, first step, bring the first number underneath the line. That 3, we bring it down. Then you say the 3 on the outside times the 3 that I put under the line, you multiply them. 3 times 3, 9. You write the answer on top of the line. And you're always going to be adding these numbers. It's always addition. You know, in algebra, addition sometimes requires adding numbers that have different signs, and that's okay. But you're always adding them, right? So 3 plus 9 is going to be 12. And then you multiply the 3 on the outside again times the number that you got here out of the addition. 3 times 12, it's going to be 36. And then you add again. So -5 plus 36 would be 31. Oops, I put the 1 too far away from the 3. 31. And then again, 3 times 31, 93. And then you add these two numbers. So 96. Now, this number at the very end is kind of special. This is what we call always the remainder. So, the thing here is that how are we going to write the answer? These numbers that you see here, the ones that I'm putting arrows on, are going to be the coefficients of a new polynomial that will start with an exponent that is going to be one less than the highest exponent you can see on the long polynomial, or the first one that you're given usually. So if the highest exponent on the original polynomial is a 3, like we can see, then you should start with a term that has an exponent one less than that, so an x to the second power. The 3 that I put at the front, it's basically this number that you see here. So those are going to be your coefficients. Then the next number, the next coefficient is a positive 12, so you're going to put plus 12 x to the first power, because the exponents need to be decreasing one after the other. So x to the first, just put an x, we know the exponent is a 1 even though we don't see it. And then the next coefficient is just a 31. Why am I not putting x's because on the 31? Because remember that the exponents need to be going lower from left to right. So x to the second, x to the first, no x on the 31. That means the x has a 0, but we don't see the x, we don't see the 0 either. Now the thing is that because we have a remainder, remember, how are we writing the answer? This would be our quotient. This would be our q of x. And then the remainder is going to be plus 96 over the divisor. So this would be the remainder. The divisor is what you were dividing by. Now you may think, just the 3 that's on the outside of the division. Nope. The expression x minus 3, the original expression that the first polynomial was being divided by. That would be your divisor. So that's how you work with synthetic division. It's kind of easier, that's my opinion, compared to long division, because you simply do not deal with the exponents and the letters so much as long division. Some people may agree with me, some may not, but that's basically how it is. That's what I think, but it's up to you. The only condition with this one, with synthetic division, is that the only time that you can use synthetic division, I'm going to tell you, it's when the expression that you are dividing by, the small one, there's two conditions. The x needs to have an exponent of 1 on it, like this one has a 1. And at the front of the x, the coefficient should also be a 1. If you see other numbers at the front of the x, like 2, 3, 4, -5, or whatever, or the exponent on the x is not just a 1, then we are forced to do always long division. Okay? But if the x is just by itself, x minus 3x plus something else, then we can do synthetic division. But if it is something like this one, look at what you were dividing by, the divisor 2x squared. Because of the 2 at the front, because of the 2 on the exponent, we couldn't do synthetic division. Okay. But for example, with this one, if I do synthetic division or I do long division, which you know it's completely different processes, the answer, even though the processes are the same, the answer is supposed to be exactly the same thing for both processes. In this specific case, where the x has a 1 at the front, has a 1 as the exponent in the small polynomial that you're dividing by. Okay. So synthetic division here, we do the same thing. Let's check for the coefficients. 2x to the second. Oh, look at this one. This one is in disorder. Before you do anything, I was going to already start writing down the coefficients here, but I told you that first of all, we need to arrange this in the right way. So what's the highest exponent? X to the fourth. This one needs to go first. What's the next one? The negative 3x to the third. What should be the next one? Plus 2x squared. And the next one, minus 6x. That's divided by x plus 3. First the x that is raised to the first power, then the 3 that has no exponent, which technically is a 0. So 1, my coefficient here is a 1 even though I don't see it. 1, negative 3, 2, negative 6. And this one, I was going to tell you something about this, but then I remember. On this one, you see how usually, like, this one ended up with, started with 3, the exponent here, the highest 3, to 1, 0, no exponent right over here. But this one, ours is 4, 3, 2, 1, but then there's no constant term. There's not a term that is only a number and has no letter next to it. It stops at a term that has an x to the first power. So due to that, you have to put a 0 to represent that space, that missing term that you don't have, that constant. So now I go to this part, x plus 3 equals 0, minus 3, x equals negative 3. Then we move forward with bringing down the 1, multiply negative 3 times 1, it's a negative 3. Adding these two numbers, so that's a negative 6. Negative 3 on the outside times a negative 6, positive 18. You add this to 20. Negative 3 times 20, negative 60. You add this to negative 66. Negative 3 times negative 66 is going to be a positive 198. So you add this to 198. So the remainder here, this is my remainder, okay, and this will represent my quotient. So the numbers, remember, here are the coefficients in front of the x's, right? So 1 x to that, remember, start with one exponent less than the highest exponent of the original first polynomial, so start with an x to the third power. Is the 1 at the front necessary? Not really. We know that when an x has no number at the front that we can see, it's a 1. So as a matter of fact, I'm going to take it off, because I want you to get used to not seeing it there, so that you are aware of that. So minus 6x squared, start decreasing the exponents consecutively, plus 20x minus 66. You can see the exponents 3, 2, 1, 0, no exponent. Plus 198 plus the remainder over the divisor. The divisor being x plus 3. The expression you were dividing by, not just the negative 3. And that's what it is. Okay. So that's it for that one. Divide using synthetic division. Okay, so let's do this one. Keep in mind that I told you that you need to have, from left to right, greatest exponent decreasing one after the other. But this one looks like it's not arranged in the way that we are supposed to have it. It jumps from something that has an exponent 5 to something, the 243, that has no exponent, or where the exponent is 0. So what do we need to do to fix this one? We're going to have to do plus 0x to the 4th, plus 0x to the 3rd, plus 0x to the 2nd, plus 0x plus 243. So probably move this somewhere else, because it's going to take some space from us. So do you see what I did? This and this and this and this term were the ones missing in between these two. Okay, 5, 4, 3, 2, 1, even though we don't see it, and then 0. So when you do your synthetic division, now we're going to write a 1. Where is this 1 coming from? From here, the coefficient. You're not copying the exponents, you're copying the coefficients. 0, 0, 0, 0. There's 1, 2, 3, 4 zeros. I have 4 zeros. And then 200. And believe me, it makes a difference if you do not put the zeros that you need to, the ones that you're supposed to, then you're probably going to get the wrong thing. another answer that is not right. Minus 3, x equals negative 3. Negative 3 times 1, negative 3. 0 plus a negative 3, negative 3. Negative 3 times a negative 3, positive 9. 0 plus 9, 9. Negative 3 times 9, negative 27. 0 plus a negative 27, negative 27. Negative 3 times a negative 27, it's a positive 81. So 0 plus 81, 81. And then negative 3 times 81, it's going to be a negative 243. So the remainder here is 0, because when we add these two, the answer is 0. So that means our quotient is the only thing we're going to be able to write. We don't have a remainder, and that's fine. X to the one exponent less than the highest exponent you see here, so x to the fourth. That's how you start. Minus 3x to the third power plus 9x to the second power minus 27x plus 81. Where is this one that we started with? It's at the front of the x to the fourth. So we only have a quotient, but I'm telling you that's okay. Okay, the remainder theorem. It says if the polynomial f of x is divided by x minus c, then the remainder theorem is f of x. So what about this theorem? Okay, how do you use it, or what do you use it for? It says use synthetic division and the remainder theorem to find the indicated function value. I'm going to show you how the theorem is applied, and then I'm going to show you a little shortcut. Okay. So what's the actual remainder theorem? What we're going to do here, which deals with synthetic division. So you're given here, this is your polynomial f of x, then there's a semicolon, and it says f of negative 3. So what you have to do is the coefficients of this polynomial, making sure about the exponents and so forth, 3, 2, 1, 0, decreasing consecutively, which they are. You're going to write them down here. On the outside, you're going to copy exactly the number that you see here. You're going to put it on the outside. Negative 3. So you're going to do synthetic division. You bring down the 3, negative 3 on the outside times the 3 that you brought down, negative 9, and then you're adding these numbers, remember, all the time. So it's going to be 10, 11, 12, 13, 14, 15, negative 15. Negative 3 times the negative 15, it's going to be a positive 45. And then you add this 2, so you get a positive 40. Negative 3 times 40, negative 120. And then you add this 2, and you get negative 113. So again, the last thing, it's always my remainder. So we write down the answer, which is going to look like 3x to the one exponent less than the original polynomial to the second minus 15x plus 40 minus 113 divided by, sorry, I was writing the answer down. We don't need, yeah, that's what we were doing, right? Writing the answer. Now, what about this whole thing? Like, I forgot, I was thinking it was just doing the synthetic division of the other one. So we have already figured the answer by doing synthetic division. We have found the indicated function value. They were asking you what's the function value using the remainder theorem by using synthetic division of f of negative 3. So the answer here is the remainder. F of negative 3 is equals to negative 113. Sorry about that. I don't know if you heard my dog. Just ignore that sound. He was growling. Okay, so what is the shortcut? The shortcut here to using the actual remainder theorem, it's going to be substituting into every x in the polynomial that value. Okay, so you have 3 times, I'm leaving the space so that in every x I'm going to put in that number. Right now I'm going to substitute it. Sorry, I put a 6 and it's a 3. Here, so 3. So here I'm going to be putting a -3, a -3, minus 6x squared, minus 6, parentheses square, -3, minus 5, -3, plus 7. Okay, we can do this step by step, and I was going to, but I mean, you can use the calculator. There's no need for you to do this by hand. So bring in the calculator, and we just simply put in all this in the calculator. So 3 times -3 to the third minus 6 times -3 to the second power minus 5 times -3 plus 7. You can see what the answer is, and as a matter of fact, let me take a picture of this and add it here. You can see that the answer is, sorry, it went up again. The answer is for f of -3, the answer is -113. So this is a shortcut instead of actually using what the remainder theorem is. Now, do you want to do the remainder theorem just to find out the remainder, or do you want to do this? It's up to you. It's the same thing. But whenever you have a question that says this kind of instruction, that's what you have to do. Okay? Let's do it with the shortcut. Let's do it with the calculator. So basically we're saying that every x will become the -1/2 that you see inside of the parentheses on the f of whatever. Okay? Minus 5 to the third minus square plus 3 plus 2. So let me put it in the calculator. 2 times -1/2 squared, not squared, to the 4th power minus 5 times -1/2 to the 3rd power minus -1/2 to the 2nd power plus 3 times -1/2 plus 2. So the answer is 1. Okay, so out of all this we get a 1. Let me take a picture again of the calculator. So this is the remainder theorem, but we did the shortcut to the remainder theorem. Okay, the previous one I showed you with the long way. Now we have the factor theorem. What's the factor theorem? It says let f of x be the polynomial, be a polynomial. If f of x equals 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c is equals to 0. Okay. So here we have, solve the equation x to the third minus 5x squared plus 2x plus 8 equals 0, given that negative 1 is a 0 of f of x, equals x to the third minus 5x squared plus 2x plus 8. So, let's see. Okay, solve this, right? Solve for what? Well, probably for x. We're always solving for the variable, right? Given what? Well, the given to me to start the process of solving for x, it's this number. See what it says. Given that negative 1 is a 0. What do you mean negative 1 is a 0? It's not that negative 1 is the number 0. Obviously, we know that, right? Remember, in the previous section, I told you that the word zeros are the same thing as solutions, sometimes x-intercepts. So here they're telling you that this is one of the solutions of this polynomial, or this equation, but you have to solve and you have to find the rest of the solutions. This polynomial, if you look at this one or this one, which is the same, so they're telling you that this negative 1 is a 0 of this given polynomial. The degree of this polynomial is 3, right? Where am I getting that from? From here, the highest exponent. So, let me take away this. You remember that concept before, right? When we saw 3.2, we said the degree of a polynomial is the highest exponent of n. So the degree is 3. That is an indication of how many solutions that polynomial should have. If your degree is 4, you have 4 solutions. If your degree is 5, 5 solutions, and so forth. They're giving you one solution, the negative 1. In total, there are 3. So that means we are missing 2, and those are the ones that we need to find. So what are you going to do? You're going to start doing synthetic division with the coefficients of this polynomial. What are the coefficients? 1, negative 5, 2, and 8. And the exponents are written in perfectly order. 3, 2, 1, 0. Okay, no exponent. What number are you going to start doing the synthetic division with? The one that you were given as one of the solutions of this polynomial. You need to use something to start with. So, bring down the 1. Negative 1 times 1, negative 1. Add these two answers, so that's a negative 6. Negative 1 times negative 6, positive 6. Add these 2, so that's 8. Negative 1 times 8, negative 8. Okay, so here my remainder, it's negative 8. Negative 8, I'm sorry, it's 0. Sorry, I copied the other number. It's 0, right? Because when we add this 2, it's 0. What about this? That means that I did this process of the synthetic division perfect. Because if a number is a solution of a polynomial, when I do synthetic division with that number, using the coefficients of the polynomial, the remainder should always be 0. If I wouldn't have gotten 0 right now, that means that probably I did a mistake, a Carlos mistake somewhere. Okay. So just in this kind of problem, when they're giving you a number to be a solution of a polynomial, that number is not just any number, it's a special number. So the remainder has to be 0. So what to do from here? Well, you're going to write a smaller polynomial, right? In degree. So 1x to the second power, because the highest degree over here, the highest exponent or the degree was 3, right? So you start with an x to the second. The number at the front is a 1. I'm not going to write down the 1. You know it's there. Minus 6, x to the first power, plus 8. Since there's no remainder, I mean, that's what it is. Now, what about this? These are not the solutions. We need to find solutions that look like numbers like this, right? So, equal this to 0. Let's try to see if factoring would help for us to find the solutions. That would be one technique. Use factoring right after you get this polynomial. This looks like a trinomial, so we know that we factor as x times x gives us x squared. Then we need two numbers that multiply together gives us 8, but added together equal to 6. So what about 4 times 2? Those are perfect. Negative, because whatever sign the middle term has, that's what you use for the first parenthesis. If you have a plus at the end, repeat the same sign. So it worked out. Factoring worked out. Okay. So what to do now? You already know this. To solve for x, break this into smaller equations because you're using the zero product principle. When things are multiplying together, they're set equal to 0. You can break them apart and solve for x individually smaller equations. So x is 2. So x equals 4, x equals 2. You got two solutions plus the one that you were given, the negative one. Those are the 3. That makes your degree 3. So what are the solutions that you just found? These ones. But what are the total solutions? X equals 4, x equals 2, x equals negative 1. The order in which you write them really doesn't matter. Those are the 3 solutions. Okay. What we are doing is we're finding the solutions of a polynomial when you're given one of the solutions. So your first step is always using synthetic division with that number that you're given. Use the coefficients of the polynomial, create a new equation or any polynomial, and then try factor. Factoring is going to be the first thing that you want to try. If it is factorable, perfect. You can get the rest of the solutions. And just make sure at the end, degree 3, okay, I need to have 3 solutions. Degree 4, I need to have 4, and so forth. Okay? Next one. Solve the equation given here, right? So we're finding the same thing, given that negative 3 halves is a 0. Okay. So first step, synthetic division. What are my coefficients? 12, 16, negative 5, negative 3. Look at the exponents. 3, 2, 1, 0. Perfect. On the outside, negative 3 halves. You don't have to change the sign of the negative 3 halves, okay? That's only when it's written as an equation, x minus something. I mean as a polynomial, but not right now. Right now you just use it the way that it is. So you bring down the 12. Multiply these two numbers. If you're like, how do I multiply fractions? I mean, just get the calculator. Put parentheses, negative 3 halves times 12. Negative 18. I mean, you could do this by hand, but if you can't or don't know how, just get the calculator. 16 plus a negative 18 would be negative 2. Then again, negative 3 halves times a negative 2, 3. Negative 5 plus 3, negative 2. So the same thing, negative 3 halves times a negative 2 would be the exact same thing, right? 3. Which tells me that my division, I did it accurately, I didn't do any mistake, because remember what I said, the remainder has to be 0, because the number you're using to divide by, the negative 3 halves, is not any number, it's a special number because it's one of the solutions of this polynomial. So what to do next? Write a new polynomial 1 degree less than the degree of the original polynomial, meaning 1 exponent less than the highest exponent in the other polynomial. 12x to the second power minus 2x minus 2 equals 0. Okay. We can try factoring as always. And I know you're going to say, oh, it's a trinomial. And I was going to do that too. But then I said 12, 2 and 2, they're all divisible by 2. So yeah, we can factor, but we're going to factor at greatest common factor first. 2 times 6x squared, it's 12x squared. 2 times negative x would be negative 2x, and 2 times a negative 1 would be negative 2. So then from here to this can be factored again. Now let's see if we can as a trinomial. Just keep in mind this trinomial has a number at the front that is bigger than one, that changes things a little bit. First, ignore that 6, right? X times x, x squared. But then we do 6 times 1, ignore the negative. 6 times 1 is 6. So we think two numbers that multiply together gives us 6, just these two, right? But subtracted, they need to equal to 1 in the middle. The coefficient of the x in the middle is a 1. So subtracted, the only two that would work would be these two. 3, 2, minus, plus. So technically, since we have 3 factors, right, you're supposed to equal to 0 all of these factors. The thing is that what are you going to do with the first one? Nothing, because it's a false statement. You're just going to ignore it. There's not an x to solve for, and obviously 2 is not equal to 0. So just go ahead and solve the other two equations that actually have an x. And the other one, because you just ignore it. X equals negative 2. So this polynomial was again degree 3. Remember, that's an indication of how many solutions the polynomial should have. So you should have a total of 3 solutions, which you do. 3, negative 2, and the one that you were given since the very beginning, negative 3 halves. Okay. And let's look at the last one. So this was a pretty similar problem, except for the factoring, except for the fraction that we had to deal with, but I mean, we had the calculator to survive. So it says here, okay, we were given a polynomial, we were finding the solutions. Solutions are the same thing as zeros, also the same thing as x-intercepts. So here it says, use the graph to determine a solution of the equation. This equation that you see here, it's this graph that you see here. Use synthetic division to verify that this number is a solution of the equation, then solve the polynomial. Now, which number are they talking about? Well, I just told you that the word 0 is the same thing as a solution. It's the same thing as an x-intercept. Right? So this, it's an x-intercept. On this curve, on this piece of this polynomial, maybe it's not the entire polynomial, they're just showing us a piece of it. This is one of the solutions. It says here, verify that this number is a solution of the equation, then solve the polynomial. Basically, they're asking us to do what we did. How are you going to verify that it's a solution? Do a synthetic division. Put that 3 on the outside, okay, and then copy the coefficients of this polynomial. 1, 7, 7, negative 15. All the exponents are the way they're supposed to be. So you're going to bring down a 1. 3 times 1 is 3. 7 plus 3 is going to be 10. 3 times 10, 30. You add this 2 is 37. 3 times 37 going to be 111. You know what, I'm thinking, why did I put a 3? I guess I copied this number. Isn't it a 1? Because look, I'm seeing over here 5. Yeah, sorry, 5. So this must be 4. This must be 3, this must be 2, so this must be 1. I made a mistake, I don't know, I copied, sorry. The other number that I was like, no, it's not a solution, but it's an x-intercept, so it had to be. If you see that a graph crosses or touches the x-axis at a certain number, that's an x-intercept. And it should give you, it must give you a 0 in the remainder, but yet I wasn't going to get it right now, and that's why I started thinking, What did I do wrong? Sorry. So, okay, up to there. So, I bring down this 1. 1 times 1 is 1. This is an 8. 1 times 8 is 8. This is 15. 1 times 15, there you go, 15. And I was adding all these numbers, right, all the time. So we got here a 0. X to the second plus 8x plus 15. Okay. So what to do from here? We're gonna, okay, we set it equal to 0. We're gonna find the rest of the solutions because it says, okay, up to here I verified. Is this x-intercept or that number of the x-intercept a solution of this polynomial? Yes, because I got a remainder of 0. So I checked for that. Next thing is solve it. You already know how. Just factor. X times x, x squared. 15, you have 1 times 15. You have also 3 times 5. And you need two numbers that when you add them together, they're equal to 8. So it has to be 5 and 3. Plus, everything's plus. And so x plus 5 equals 0. X plus 3 equals 0. Minus 5, minus 5. So x equals negative 5. Minus 3, minus 3. X equals negative 3. So these are the rest of the solutions. So the degree was 3, right? Degree was 3. That means we should have 3 solutions. We do. The one that you saw here on the graph, that's one of the solutions. And then the 2 that you got, those are the 3. So that means we stop. That's it. There's no more solutions. So this is section 3.3. Okay. If you have any questions, please let me know. Thank you. Sorry, I'm trying to stop the recording and I don't find where I send it. There.